Okay, so good morning to everyone who's joining us for this morning's Reactor session, or good afternoon or good evening, depending on where you're joining us from today. This morning's session is how vulnerable is your Azure environment? And we're delighted to be welcoming David, who will be delivering this session today. And David is a Microsoft MVP and independent Azure security consultant. So really looking forward to the next hour with David. As I mentioned, the session is 1 hour. You have the opportunity to ask as many questions as you'd like throughout. So please feel free to pop them in the Q&A and we'll make sure that they are answered by the end of the session. So I will be moderating the session. I look after the Microsoft Reactor London and Stockholm, so I'll be in the background looking after those questions today. And this session will be recorded, so for anyone who's wondering, you can look back at it again. So I will be posting this session onto our Reactor YouTube channel. Once that link is live, I'll post it in our meetup group and you'll be able to access the recording there. So I'll hand over to David to kick us off with today's session.
Okay, thanks very much for that lovely introduction, Emma. So hello, everyone. So welcome to this Microsoft Reactor London event. So I hope you're all doing okay in the current conditions. I hope you're keeping safe as much as possible. So I will be talking with you today, as Emma mentioned, about how vulnerable is your Azure environment, and also about the approach to take in a breach scenario. So just a few useful information that I'll be sharing with you today. So, but first, a quick information about myself. So my name is David Okeyode. So I'm a cloud security consultant. I help organizations to secure their Azure and cloud environment. So that's what I do. I do that through expert level training and assessment of their environment. I have about a decade of experience in cybersecurity, ranging from consultancy, design and implementation. I have developed multiple just vulnerable by design templates that you can use to do sort of like a pen testing practice of an Azure environment. So you can check out my GitHub link. So there's some very interesting templates that you find there. So I've also authored like courses on cyber or cloud security on popular online learning platforms. And as Emma mentioned, I'm a Microsoft Azure MVP. So enough about just an introduction of myself. What I'll do now is I'll just go to introduce the agenda for today. So in terms of what I'll be covering in the few minutes that we have together. So first of all, I'll just talk about why I'm taking a different approach. Because at the end of the day, what we're talking about is cloud security. We're talking about Azure security. But increasingly, I'm finding the need to take this different approach when I talk about it. And I'll talk about the reason for that at the beginning. So I'll also talk about Azure rules of engagement. We're going to be talking about things like techniques and tactics that attackers use. And we're going to be simulating those sort of tactics and techniques. We have to know that there is a boundary in terms of what we are allowed to do and what we're not allowed to do. And we have to play within the rules of engagement. So I'll introduce the Azure Attack Matrix. The MITRE Azure Attack Matrix framework is out there, but I also introduce one that I use personally. I'll talk about just different scenarios that attackers use to find your Azure services and to exploit them, talking about different options that they use to steal credentials in Azure environment and also to exploit them. I'll introduce two tools, maybe not in details again due to the limitation of time. I'll introduce two tools at the end of that in terms of tools that attackers again could use to find what's going on in our environment. But first, just a quick recap. So security is one of the pillars of a great Azure architecture, right? So unfortunately, in some cases, it's left essentially behind functionality, right? So we essentially get things working, get it scalable, get it highly available. Oh, okay, then let's think about securing it afterwards, right? One of the things that you find is that in today's world, that could be a really dangerous strategy that you're taking of leaving security to the last, right? Because attacks are getting more sophisticated, they're getting more quicker in terms of the time of discovery of a vulnerability and the time to exploit of that vulnerability that's getting shorter and shorter. So in other words, we have very, very short time between we have something that's vulnerable out there before somebody exploits it. So security essentially needs to be a normal part of our procedures and processes as an organization. Security should not be something that comes as an afterthought. As part of the very ideation of software development, security should be in that conversation, right? And there's a good reason for that. Bad security decisions are made right from the time of ideation. So we talk about containerization and containerized workloads these days. Well, bad security decision starts at the very beginning when you're picking your base image. So you have to be involved as security team right from that very beginning, right? It also begins when you're using your Docker files or your templates to automate the build of your container images, putting credentials in them. So those are the sort of things security needs to be part of that all the way from the beginning. So, but why am I taking a different approach, whenever I talk about security these days? So here's the reason for that. So there's a lot of presentation talks, videos that already focus on best practices and how to use different tools. So that's not something that's new or that's something that's special. It's important, right? Don't get me wrong. That's absolutely important for us to learn how to use tools, for us to learn the best practices. And I'll be talking about some best practices today also myself. That's absolutely important. But I find out that there's a lot of information out there already. You could go on YouTube and you can find literally tens of thousands of videos on best practices of cloud security. Also, understanding an attacker behavior is an important part of cybersecurity education. So we are well familiar of that. We know from our on-premises experience that ethical hacking, right, and offensive security is an important part of cybersecurity education. That's why many organizations are adopting the approach of red team, blue team. They realize that they have to think like an attacker and try to see if they can exploit vulnerabilities in their environment before the actual attackers focus on your environment. So that's an important part of cybersecurity education. So what I'm just talking about in this case is bringing that same approach to talk when we talk about cloud security, bringing that same approach to that. Also, it's important to learn what not to do from the failures of others, right? So one of the things that I'll be walking you through is a sample or a demo attack chain, and that's something that happened to someone in the past, right? And you know, we learn from the failures of others. When that happens, we don't just go, yeah, you know what, let's just laugh at that. Let's laugh at, you know, what's the decisions they made. What we go to do is, or what's good for us to do is to go, what can we learn from this, right? How can we prevent this in our own environment, that kind of issue. So whenever we talk about just offensive Azure security in general, just offensive security, the MITRE attack framework usually comes up. And for those that are not familiar, so the MITRE attack matrix, so that's a globally accessible knowledge base of that has adversary tactics, techniques, and procedures that the attackers use to attack different environments. So they have a matrix out there for Azure right now. So you can go to the URL that I have on the screen, and you'll be able to get the MITRE attack matrix for the Azure platform. However, I have it here also, so you can see it details different tactics and techniques, all the way from initial access to persistent privilege escalation, credential access, and impact, and just other types of procedures. So it details the tactics that attackers use. However, when I talk about this, I like to use my own attack matrix because I have flexibility to add things, to move things around. I don't like to tamper with the work of MITRE, so I leave their work alone and I just focus on my own aspect in terms of, I have my own attack matrix that I use when I talk about this. I can move things around. In terms of the demonstration that I'll be showing you today, here's what the environment will look like. So we're going to start really from nothing. We're going to start from, we have an attacker that's looking to attack an Azure environment or a victim environment with nothing. And at the end of the demo, we're going to end up with this, where the attacker has been able to exploit vulnerabilities, open backdoors into the environment, steal credential tokens, just using different methods. But before we proceed to talk about that, it's important that we clarify what the rules of engagement are, right? So it's sort of like a quick warning. If you're going to be doing things like ethical pen testing of your Azure environment, you have to do things within boundaries. So if you go to the URL on the screen, you see Microsoft document on what the allowed rules of engagement are. So I won't go into details of everything that's on that list, but essentially what the summary of it Summary of it is, whatever you're doing should not have an impact on other Azure customers. So remember that this is a shared environment. This is not an environment that's exclusive to yourself and your organization. So whatever you do, don't impact other customers. In other words, when you're doing like a scan, if the public IP address is not currently allocated to your service and your workload, do not go scanning that. That is not allowed, right? Because now you're impacting other customers. Right, so doing things like distributed denial of service attack, that's not allowed, because again, you're attacking a platform that other customer workloads are hosted on. But give that URL, go to that URL, give that document a read to understand what the rules of engagement are. It's important to clarify that if you do not follow the rules of engagement, if you're doing ethical hacking of Azure environment from your Azure account, that could lead to your account being suspended or being terminated by Microsoft. It could also even lead to legal action being brought against you by Microsoft if you go outside of the allowed boundaries. And you could even be liable financially if you do things that affect other customers. So we have to be a bit careful here and understand that whatever we do, you have to focus on your workloads and your workloads that you have implemented, and only that are you allowed to touch, and nothing that can impact other customers. But again, when we talk about like the just attackers and the tactics and techniques that they use to attack Azure, it's very similar to what happens on premises. You start with the Recon stage. In other words, we're trying to identify potential targets, right? What targets are housed there? What services do they have running? What services do they have exposed? Do they have any vulnerabilities in them? So we're starting from that perspective, just trying to see what's the target surface area, what's available, what's the vulnerability of the target. So that's where we start from. But how will an attacker do this from an Azure perspective is what we're talking about here. To understand that, we have to understand how the Azure architecture looks like and how an attacker could go about something like that. So here's an example of just a structure of what the Azure architecture looks like. So the Azure platform actually has 4 cloud environments. So there's 4 Azure clouds. There's the Azure Public Cloud, there's the Azure US Government Cloud, there's the Azure Germany Cloud, which is a sovereign cloud and environment in itself, and there's also Azure China. So that are the 4 cloud platforms that Azure has. And all of these cloud platforms have their own Azure AD instances, or have their own Azure AD environment. They have their own API endpoints that is different from the other one. So the Azure Public API endpoint is different from the other one. And also the IP address ranges are also different from each other. So in terms of the regions that we have, so apologies here, I'll quickly get my curtain because the sun is coming right on my face. So that's better. Okay, so in terms of like the regions that we have, so the Azure Public, we have about 40 regions. Azure US Government has about 7 regions, including secret regions that the locations are not disclosed. Azure Germany currently has 2 regions, and Azure China has 4 regions. Also, Microsoft has announced 8 new regions that they are currently building. So that includes locations like Mexico and Spain and Italy and Poland. So we have more regions that Microsoft are releasing. Also, it's important to understand what the Azure Resource Hierarchy is. So at the top of the Azure Resource Hierarchy, we have Azure AD, which is the identity provider. That's the cloud identity provider that we use to authenticate for access to our cloud resources in our Azure subscriptions. Then we can have like a root management group, which is sort of like this structure that allows us to group subscriptions together and manage them together. So just simplifies management and reporting. Then we can have child management groups, and then we have a subscription within the child management groups, and then we have resource groups within the subscriptions, and then we have our actual resources. So the reason why I bring this up is that when we get to like the credential theft scenario, you see that it's important if a credential that's being compromised or stolen, if the credential has access, for example, on this level, right, there's room to be able to move laterally to other Azure subscriptions within the environment. So essentially it depends on which level of access that the person has. But we have to understand these if we're going to be going through those processes. So, but how attackers find services? So just a cloud IP provider scan. So Microsoft publishes the list of Azure public IP addresses. So we can actually just go download that from the internet. So it's a JSON file that Microsoft has published on the internet. And attackers could take that downloaded JSON file, they could pass that to essentially focus on different services. So for example, we could pass that IP address range and identify just public IPs that are used by UK South virtual machines in Azure, and then target those, or that are used by app services, or that are used by containerized services like container instances, Kubernetes service, and just target those. So an attacker could use a tool like JQ to pass that, and then to try to obtain what the IP address is for those services that they're targeting at. So, and again, you could drill that down to actually say, I only want to get the IP address that's used by Azure App Service in UK South, knowing that people host applications on Azure App Service, and some of the applications would be vulnerable. So then an attacker could just target their scan towards that. But then there's also like the case of platform services. So what about platform services? So things like your storage accounts, your SQL databases, your MySQL databases, Cosmos DB instances, cognitive services. So all those types of platform services, you find out that Microsoft has like several domain names that are used by those services. An attacker could, for example, just use DNS style attacks to try to identify resources that are not configured correctly. So in the case of services like Azure App Service or Azure Function Hub, the DNS suffix is Azure Websites.net. So an attacker could just pass a word list with that DNS suffix and try to identify potential targets that way. And it's the same for multiple other services in Azure. You see that the services or platform services usually have DNS suffix that's associated with them. So that's one of the lists, is a continuation of the list depending on the service that we're talking about here. So for example, Cosmos DB, so that's sort of like the DNS suffix that's associated with that. So again, an attacker could then take that and do like a DNS enumeration, maybe query search engines with the DNS suffix, looking for public services that they could exploit. Maybe perform a DNS brute force discovery with word list, and there are different tools that we could use that already exist that could be used to do this. Right. But at the moment, the attacker is just identifying targets. Just looking for targets to that, and then identifying target, identifying the surface area, what's running, what's not configured correctly, what can I exploit. So that's just information gathering. It's not a vulnerability yet. It's not exploiting anything yet. And then we have like the credential theft scenarios. So, and credential theft scenario is talking about the techniques that attackers use for stealing credentials. So, and we'll talk about that in more details in the next few slides. So the techniques that are used on premises actually apply in this scenario also, but there are some Azure specific techniques that attackers use. And some of that I'll talk with you in the next slide. Now, for us to be able to understand like the stealing of credentials, it's also important to understand this thing called Azure Resource Manager, because that's a typical target for attackers. And you see the reason why once we go through the slide. So whenever you want to manage Azure, you want to deploy services and resources into Azure, there are very limited options that you really have, right? It's either you're using tools like the Azure Portal, Azure PowerShell, Azure CLI, you're using REST client, or you're using the Azure SDK. So those are the options that you have whenever you want to interact with the Azure platform as an admin or as someone that needs to gain access to certain services. The thing about Azure is, regardless of which tool that you're using, you're communicating with a single endpoint called Azure Resource Manager. You can think of Azure Resource Manager as the central service for interacting with Azure. So regardless of which tool you're using, you're all coming in through the same endpoint. And the way Azure Resource Manager works is to authenticate to Azure Resource Manager to get access. You have to authenticate using Azure AD, and you also have to have authorization using role-based access control. And what that means is this method is consistent regardless of the tool. You have to authenticate using Azure AD, and you have to have authorization using role-based access control. Now you could be authenticating using a user account, you could be authenticating using a service principal, but you have to authenticate anyway. And after you've authenticated, you have a token issued from Azure AD, and now you can gain access to the resource provider to be able to do management of your services and your resources that you have. Also, there are some services in Azure that also have direct integration with Azure AD. So services like Azure Storage, Azure Blob, and Azure Files have integration with Azure AD. right? Services like Azure SQL has integration with Azure AD, where you can actually authenticate to those services directly if you have an Azure AD token. So it's not only just the management plane, there's actually some services in Azure. I believe probably about 12 of them at the moment that have integration with Azure AD. So there's the reason why this diagram is important. Now, if you're an attacker, you could imagine that that resource manager is very important to you. If you can gain access to that, right, you can essentially use that as the landing plane to gain access to other things. So that's very important for an attacker just trying to gain a credential that will grant them access to Azure Resource Manager. And the way that Azure Resource Manager works, we mentioned that you have to have a token from Azure AD to be able to access that. But what options do we have to get a token? Because that's what an attacker will be targeting. You can either use an Azure AD user account, which is just identity for your users. You can use an Azure AD service principal, which are identities for your application resources. And you can use a managed identity, which is where you associate an identity with an Azure service, and then it can transparently obtain a token from Azure AD in the backend. So that's another option that you can use to get an identity. And I'll be showing you how an attacker will exploit this shortly in the demo. So you can use an Azure AD issued access token. Now, just a quick word about this one. This one is a bit more sinister than some of the others, in my opinion. Right? I think this one is a bit more sinister. Here's the reason for that. Okay, if an attacker says, I'm going to try to compromise a user account, many organizations are implementing something called MFA, where now you have to do two-factor authentication. So essentially, if you just manage to do like a phishing attack or a key login attack with malware, right, and you get the user's username and password, you still don't have the user's device to do the second factor authentication. So essentially, that's getting increasingly more difficult, right, to be able to do that. Also, attackers are doing things like, the Azure AD service principles that's now being stored in things like Key Vault, and that's what people should be doing. So storing those kind of information in Key Vault and accessing them programmatically. So that's also getting increasingly more difficult to obtain, right? And this one, you actually have to compromise the resource to be able to obtain a token this way. Now, we'll do that in the demo, but essentially they're getting increasingly more difficult. But with this one, the last one here, right, Azure AD issued access token, because at this point, the user already authenticated, the user already did an MFA, they've already completed MFA, they have a token, and then the attacker compromises that token. So in that case, you've actually just bypassed the needs to be able to, bypass MFA. You've already bypassed MFA at that point because you already have a token that's been issued by Azure AD, and you're just using that token as if you're the user. So that's a bit more sinister, and you find examples of this. So malware that infects administrator systems and just transfer cached tokens from administrator system and transfer them out to a command and control center or to a storage service somewhere. And that's something that's getting increasingly popular. So how do an attacker, let's clear the screen a bit. How do an attacker get access to any of this? So here are different options that an attacker uses. An attacker could target users and admin with phishing attacks, and again, just different options to try to get access to their user name and passwords. So they could target DevOps systems, so source control systems, your CI/CD tools like Azure Repos and Jenkins, and whatever other tool that you're using in your organization. So it's possible that developers are putting service principals in these tools, and attackers could target them to be able to steal service principals from them. So they could target administrator workstations. So that's the one that I'm talking about. So in the case of this Azure AD issued access token, an admin has already logged into this workstation, their credential is cached, and then they could target them to install something on their workstation and then just essentially transfer this cache token out into a storage service somewhere and then use that token to gain access to Resource Manager. So they could target Azure hosted application. And this is talking about the managed identity scenario. So where you know that certain services could be assigned an identity in Azure, and essentially you're going to compromise that service, maybe with the vulnerability that's in for an application that's running on that service, try to exploit that, and then being able to steal the managed identity token of that service. So those are different ways that an attacker could use to do this. So here we go. So what we're going to do now is we're going to go, let me go to the demo now, because I'm looking at the time. So let's go to the demo, and in the demo, I'll be showing you a combination of some of the things that I've talked about. So for example, using doing a cloud provider IP range vulnerability scan, identifying vulnerabilities in applications that are public that are running on the Azure platform, and also just doing the managed identity token theft to be able to compromise a token that can then be used to gain access to Resource Manager and then to be able to move around in the environment. So what we're going to be starting with is we're going to have an Azure App Service, and we're going to do a service scan of that app service, and we're going to do a vulnerability scan of that, and we're going to see what we're going to find. So at the end of that. So let's go back over here. So what I'm going to do is I've got my demo environment over here. So here I have my attacker system that I'm already logged into the attacker system as the attacker, and I have the victim environment here. So again, I'm not going to be scanning the whole IP address range, but I just want to show you how you do that. So let's go over here. So here's the document that Microsoft publishes the Azure public IP address ranges in. So an attacker again could go download this document, and it's going to give them a list of all the public IP address ranges of the Azure platform. So in this case, I've downloaded that. Again, I'm not going to be doing a generic scan, but I want to show you how that would work. So if I pass that, so now I've downloaded these documents, and then what I can do is I can then just try to identify which public IP address ranges belongs to certain services. Maybe services that I know that customers are hosting applications on. So if I run that, and it's throwing out a lot of information here, so I'm passing that. But what you see is that it's giving me, it's saying service fabric in UK South, and these are the IP address ranges associated to that, right? And you can go, and it's going to list it service by service. Container registry in UK South, those are the associated services. And what an attacker could then do is they could just pass this to remove a lot of these other properties and just get the IP address ranges, so something like this. So let's run the other one. Let's clear the screen and let's run that. And essentially just grab this IP address range for the services that you're interested in, and then run a scan against that, right? So that's something that an attacker could do. So that information is out there, and an attacker could just focus on that. So once they have that, initially you're going to be trying to obtain, what's running, what's the packet surface area. So in this case, I'm going to be using just Nmap to just identify what service is running on that potential target. So running that. So while that is running, I'll just talk to you about the command I just used now. So essentially, I want to increase the verbosity level because I want to obtain more information. So that's the parameter that I'm using. I also want it to try to detect the operating system and the services that are running on that. So that's why I'm using the A parameter. And I also want to do a service detection. So that's why I'm using the SV, but I've removed the intensity. So if I specify, I can specify the intensity level in terms of what the scan would be. So let's see. So it's identifying a few information here for me. So let's go. So once it's finished identifying that, you see sort of like the results that we'll have at the end of that. So in this case, it's identified that we have a few ports that are open, and hopefully to be able to show me some information about some services that are running, so I can see what service that's running right there. And it's giving me some other information about this, this resource that I just found. So now I know what service is running. I know what ports are open. I can then try to find vulnerabilities for that. So in that case, I'll just be, because I see that that's WordPress, I'm going to run a WordPress vulnerability scan against that. So that's running on an Azure App Service. So let's go ahead and run this. And if I run that, so what I've done in the background, just for your information, is I've added an API key from WordPress vulnerability site. So it's going to compare what it's detecting using the API key. So let's see if we find any vulnerability for this. And I can see that about 16 vulnerabilities were identified. So different ranges of severity. But the one that's probably much more interesting to me is any vulnerability that allows remote code execution. because if I keep looking at that, so some of them allow me to be able to manipulate different media files. So, so if we keep looking at the different vulnerabilities that we can find, and that one looks much more interesting, unauthenticated remote code execution. So just so you know, like vulnerable applications and vulnerable dependencies are still a very large entry point into Azure environments these days. So anyways, so we found a vulnerability that has unauthenticated remote code execution. So what we're going to do is we're going to try to exploit that. And what we're going to do is we have certain payloads that we're hosting. And this is where Azure even becomes a tool for an attacker. Because what we are doing here is we have our payloads that we're using hosted on Azure Storage, because it's using the Microsoft DNS suffix, which many organizations would not block, right? They're not going to be blocking Azure Storage account DNS suffix. So that allows attackers to be able to get into an environment that they could have found more difficult anyway. So in this case, I have a container here called exploit, and I have some payloads that I'm going to be delivering using just Azure Storage. And hopefully that's allowed through the firewall to get passed into that. So that's what we're going to do here. So the first thing we're going to do is we're going to try to, let's say that's a virtual machine or whatever that's running that application that's vulnerable, can try to obtain some local information about that. So let's clear the screen. Let's run that. And let's see what we find. Now it throws out a bunch of information, but the main thing that we can have here is we have information about just local identities on that system. So you can see that we've been able to obtain this, right? But let's take this further. Now, because we know that this is running an Azure App Service environment, we can try to identify what other information can we exploit from that. So what we're going to do is we're going to try to dump out the environment variables of this. So let me show you the screens essentially of what we're going to be doing. So let's go back to the slide very quickly, and then I'll come back to the demo. So in other words, we've done the scan, we've identified a remote code execution vulnerability on that service. And what we're going to do is we're going to try to use that remote code, we're going to use the remote code execution vulnerability to obtain the environment variable. So what developers could do when it comes to the way that they use services like Azure App Service is there is an option to pass environment variables into this service directly. And it's something called config settings that developers could use to do something like that. So they use config settings and they pass environment variables to that. Now, an attacker, once a vulnerability is identified, what you should know is that those environment settings could be dumped out in plain text. And that's essentially what we're going to be doing in this case. So we've identified that. So what we're going to be doing is we're going to dump out that environment variables in plain text. We're going to read whatever information that we can read from there. And what we'll find is we'll find that the service has a backend database that it's connecting to, and we're going to be able to obtain the user ID and the password to connect to that database, right? So let's go back over here. So if I run the second exploit, and I get that, and let's run that. Let's clear the screen. And if I run that against that environment, now again we get a bunch of information. But if I look at that, you can see that we've dumped out essentially all the environment settings that have been passed through configuration settings also. So, and there's some very interesting information that I'm seeing here, right, as a security person. So some of the information that I'm seeing here is, let's see that. I can see that, okay, it's got like a home for MySQL that it's using. I can see the resource group that it belongs to. That resource belongs to. I can see where it's storing its diagnostic logs. Here's some very useful information. That's a MySQL connection string. And essentially that gives me very useful information right there, including the password and the name and the user in plain text to connect to the MySQL database that's behind that. So if I go over here, let's put that information in there, because an attacker could always come back to use that, right? So going through it again, there's some other interesting information that's interesting to me as a security person. So I can see the database username there. What other information can I see? I can see the database password again there. And that's also interesting to me, identity endpoint. because identity endpoint means there's a managed identity that's associated with this service. So that means we have opportunity to do a credential theft, right, and steal the token for that managed identity and see what access it has. So that's very interesting. Whenever you see an environment variable of identity endpoint, it's only present on services that have a managed identity associated with them. So essentially going through that, some very interesting information already. So an attacker, for example, could take that MySQL information, go use MySQL workbench and connect directly to that and start exfiltrating data. But we're going to take that a bit further. What I'm going to do is, because we found that it's got managed identity associated, let's try to use a credential theft scenario to obtain the identity for that. So in that case, we already have the user ID and the password for that. And we can see that it has an identity associated with it. So what we're going to do is we're going to exploit the managed identity, and it's going to make a call to Azure AD, grab a token, and we're going to steal that token. And then once we get that token, we can begin to use that to make calls directly to the Azure platform via just API calls using REST client. So let's go over here. Let's clear the screen. Now for this, I'll be needing some of the information. Actually, let me run that again, because I will be needing some information that we got from this attack. So we have the identity endpoint. So that's very useful information for what we're about to do now. So I'm just going to make a note of that identity endpoint there. The other thing that we will notice is there should be an identity header. So this is to protect against SSRF. So Microsoft added an identity header, and that needs to be passed as part of a request. So let's see if we have the identity header. Yes, somewhere. Here we go. So we have the identity header. So to prevent against SSRF attack, that's why that's added. But now that we have both information, essentially we can bypass that protection. So what I'm going to do is I'm going to go back over here, and I'm going to go modify my payloads that I'm going to be using here. So let's go edit that. I'm going to pass through the identity header, the identity endpoint over there. Pass that over there. And I'm also going to pass in the identity header over here. So let's go grab that. Let's go to grab the header. Sorry, apologies. So just want to quickly go to grab that information here. Let's go. And let's go grab customer. So I'm just verifying that I have the right permissions configured for the app. Okay, we've got that. So let's copy that. Let's go back to add the header. Okay, so I'm going to save that. Now that I have that saved, we're going to try to deliver that payload and see if we're able to obtain what we want. So I'm going to go to run that, deliver that payload to the vulnerable service, and let's run that. Let's see, do we get anything interesting back? So a bunch of, again, information that we got, and here we go. So now we have an access token. So essentially what we can do is that's an identity, a managed identity access token that we've just managed to, and by default, they expire every 1 hour. So essentially that gives 1 hour for the attacker to try to obtain as much information and see if they can build some persistence in this environment over here. So what we can do is let's go over to store this as a variable. Yeah, and I'm just gonna run that. So let's go. Yeah, so let's run that. Right, and if I do an echo token, yeah, I'm got that in the token. So essentially what we're going to now do is once we have that information, so let me go back to the slide to show you how we can proceed with this attack chain. And my system is misbehaving a little bit here, but you know what? We'll see. Let's see what we can do. So my PowerPoint is just a little bit of misbehavior. So let's go back. So now that we have that, then we can begin to make calls using Azure, just Azure API. We can begin to make calls into the environment. So the API call format of Azure is you specify the URIs, the resource path, and then the query string that you're using. So for example, if you want to make calls directly to Azure Resource Manager that we saw earlier, right? We have a token for management.azure.com, and we can use this to get a list of the subscriptions in that customer's environment or in that victim's environment, right? And then we pass our token to that. Then we want to get a list of the resource groups. So now we're going through the chain. We want to get a list of the resource groups for the subscription. We can pass that information, specify the subscription ID that we got from this previous list, and we just essentially just move around the environment, try to obtain as much information as possible. I won't show you like all through like the whole situation. I'll just show you like some quick scenarios here. So what I'm going to do is I'm going to run that. Let's play the screen. So that will get me a list of all the subscriptions that exist in this environment. And here I can see that this customer, this victim has a SuperCloud dev subscription. Okay, so that's interesting. But now we have information about the subscription and the tenant ID, which will be useful information going forward. So we can copy that information. So what I'm going to do is I'm going to save that in a variable. So I'm going to grab the subscription ID information here because we're going to use it in a bit of other calls. Save that in a variable. Let's run that. And if I do an echo sub ID, now we got a subscription ID in the variable, and then we can pass that as part of other calls that we're making. So in this case, we're getting a list of the resource groups in that environment. We want to see what permission or what access that token that we have, what permission does it have. So we have a list of all the resource groups in this environment. Right, we can go forward to get a list of the resources in the environment, which is what the next one does. And again, that just spits out all the resources that exist in this environment. So now an attacker looking at that can see, okay, what other services do people store credentials in, right? So for example, looking at this, you can see that there's an Azure function over here. Again, that's another service that people typically store credentials in. Another one is Azure Container Registry with the container images, and people store credentials there. And now I could see if I could obtain another credential that will give me more persistent access in that. So in this case, if I go over here, let's go down. Let's go. So that's an Azure function that we saw, function hub, and that's the ID of the Azure function over here. And we could see what essentially what else that we could find in that environment. So let's go to run the last call, and I'll just pause there and move through the rest of the process because of time. In this case, just hunting through the environment, see what can we find. So let's put that, but I'll remove that, and I'll just put resource groups. So we have a subscription ID. So again, you know how I can share links where you can find information about how to interact with the Azure API with a token, but there's a lot that an attacker could do if a token is exposed. So it's not just about username and password, it's about also the Azure AD issued token. So we've got that information there. So let's go to run that. Clear the screen and let's run that. So we're missing the API version. So what am I missing there? So so we probably need to redo that. Resources, yeah, so let's go to grab that, and let's go over here. Yeah, so I'm missing the API version. So what I'll do is I'll just go redo that aspect. So let's grab resource group to my function name. I need to specify the API version. So let's do that again. So from the resource group to my function name. And I think that looks better now. So I've got the API version 2019-0801. Okay, so let's run that again. So get that, clear the screen. Thank you, and there we go. So we got some information about what's going on that Azure function. And again, just looking through that, I can see there's a secret key there. I can see there's a client ID there. And attacker could then use that information that's now been obtained to now begin to look through the environment. So once you see like this sort of scenario, it just helps to highlight to us the very importance of why, when we talk about secret management, the importance of that, right? So this helps to highlight, like, for example, if you're a security person in your organization, I mean, what better way to highlight to them to say this is really important stuff than to show them how this could be easily compromised in your environment. So that's essentially what this is about. So let's go back to the slides and let's bring this to a close now, because I'm conscious of the time. But if you want to see more information about this, head over to my YouTube channel. So just search for my name, David Okiode. I've got more scenarios there. Also in our Azure Meetup group, we had somebody that also focuses on this area. His name is Carl Fossing. So he spoke to us in our Meetup group. Again, we focus on offensive security in the Meetup group. So Carl spoke to us about adventures in privilege identity, in Azure privilege escalation. So he talked about some very, very interesting scenarios that you may want to find out. But again, just go to my YouTube channel. You'll be able to find that information there. So anyways, let's bring up the slide and let's bring this to a close. So what are some of the things that an attacker could, that security people could have done to prevent some of this situation? So let's quickly run through that and then we'll have time for question and answers. So here are some of the things that could have been done. Unfortunately, I wasn't able to show you Lava today, but hopefully you still got some useful information. So let's start from the initial access, right? So in the initial access phase, a remote code execution vulnerability in an environment plugin was exploited. And it's important to know that application system vulnerabilities are still one of the main entry points to Azure environment. So in this case, you're doing vulnerability assessment from development to production. I was going to show you an example of using the Palo Alto Prisma Cloud to be able to do a vulnerability assessment of an Azure environment. But again, due to time, I'm not able to show that. But again, keep an eye out on my YouTube channel. I may put a video where I show you how using something like, again, like the Palo Prisma Cloud, I could run that against my environment and identify what vulnerabilities that I have from the cloud platform perspective and obtain that very quickly. So we're talking about things like you have your static code analysis, your CI/CD implementation, security validation ongoing consistently. So you have your OSS vulnerability checks, your passive pen test, your active pen test. You're doing that all the way from development to production. Also using a web application firewall, because in some cases, there are some vulnerabilities that you're not able to patch immediately. Right, so having something like a WAF that you could, also some other type of technology that you could use to mitigate in the meantime while you work on fixing those vulnerabilities is very important in this case. So let's see some other information that we have here. So I've got, sorry. So some other information that we could do in terms of assessing our environment. Just let me fix the typo. So in terms of the VM vulnerability assessment also is very important because of the environment that your application is running on. Container image vulnerability assessment. So again, I was going to show you like, again, a demo of that. But again, very interesting scenarios here, right? There's another scenario where an attacker was able to obtain just a read-only credential. So this credential had absolutely no access to modify anything within the environment, just read-only credential. And then being able to use that to exploit images in the victim's Azure Container Registry, and then being able to pull certain information out of that allow them to escalate their privileges. So container image vulnerability assessment is very important with that. So after that, we dumped the configuration settings and found credential access to access a database. So what are some of the things that we could do for this? Enforce secret management, right? Do not put those credentials don't pass them through configuration settings to your hub services or your Azure function. You have to enforce that governance in your environment. Attackers typically look at credential hotspots like your DevOps tool, like Azure Hub Service configuration setting, Azure function configuration settings, automation account variables, resource manager deployment outputs. They look at those to find credentials once they gain a foothold into your environment. So you want to make sure that you enforce secret management in your environment. So here's an example of referencing the same information, but referencing that in Key Vault rather than passing it in plain text. So you have that database connection string in Key Vault, and then you can reference it using Key Vault referencing within your environment. You specify your Key Vault name, your secret name, and then the version or the ID of the secrets that you want to access. And that way, your application can programmatically retrieve these so that if somebody dumps out the environment variable, they can't get this information. And yes, finally, I think this will lead me to round up now. So how to prevent credential theft and database access. So in that case also, we're able to access the database directly from the internet. I know I didn't show you this part, but you see those in my videos. So, but we're able to access the database directly from the internet. Now, in that case, Microsoft has an amazing solution called Private Endpoint. If your application is running privately, there's no reason why database should be accessible directly from the internet, right? And that's not just something that you configure once using Private Endpoint. It's something that you also have to monitor on an ongoing basis in case something changes that configuration, right? You have a CSPM tool that can help to identify that, but also something that you govern on an ongoing basis. So that's very important. So that could have helped to say, even if you have the credential, you have to access it only from certain networks. So it gives more work for an attacker to do. It's not just easy to do that. Make a connection request privately and get your connection response privately, and you have access restricted from the internet to be able to do that. And in the case, we use stolen token from managed identities to explore the environment. In this case, follow the principle of least privilege. Only give permission to the resources that need it. In this case, the Azure function needed to be able to access Azure storage. And it's been given a service principal. The application run has been given a service principal that has permission to be able to read information on the subscription level. There's no need for that. Only give the permission. If it only needs to be able to access a resource in a resource group, only give permission on that resource group level. So even read-only permission are dangerous, like what you saw. So there's nothing that I showed on the screen that I did using contributor permission. It's read-only permission, being able to dump like the environment variables out. Have a security baseline for every service that you adopt in Azure. So evaluate the services, come up with best practices that fit into your framework. So best practices is still important and being able to use that. Again, look into CSPM tools and make sure that you invest in that. Okay, so that brings me like really to the end of this. So Emma, I think I'll hand over back to you for question and answers.
Great. Thank you so much, David.
No problems.
For that excellent session. We've had lots of questions come through. Just looking through them, one of the first questions from Richard that came through. So does Azure AD provide more or less the same functions as Active Directory in the data center?
Very good question. So it does. So it provides the same functionality, but it operates differently. So Azure AD provides for Azure Environment, it provides other Microsoft Cloud services, actually, not just Azure. It includes Office 365, Dynamics 365, and other Microsoft Cloud services. It provides authentication for the environment. So that's what it does. However, it uses a different set of protocols than what on-prem AD does. So on-prem AD uses Kerberos and NTLM. Azure AD uses what are called modern authentication protocols, and we're talking about protocols like SAML version 2, protocols like OpenID Connect for authentication and OAuth for authorization, and protocols like WSFed and SAML and others. So yes, the answer is it does, but it uses different protocols.
Brilliant, thank you. Next question from Zishan. But if we block host URL.azurewebsites.net at very first level?
So that URL is not something that you can block, unfortunately, Zishan. If you're hosting a service in Azure, what you can do is you could use a custom domain. So if you're hosting a service in your application on a service like Azure App Service, you have that default URL that you have to use. However, you can change that to a custom domain to begin with. However, that also actually has very little benefit from a security perspective, because what the attacker is doing in this case is the attacker is taking the IP addresses that are used by Azure App Service. So if I go back very quickly to show that to you, so what the attacker is doing is they've obtained the IP address of the Azure public region, and they're passing this query to say, give me the IP addresses of services, or the IP addresses that's used by Azure App Service only. And then once they obtain the public IP address ranges for that, they then run a scan against that. Now they could run a reverse DNS scan, which will expose and say, oh, this is used by Azure websites.net. And then that way they know that this is an Azure App Service or an Azure function. So unfortunately, that will have very little benefit in that case, because eventually what they're starting with is they're scanning the IP address range to identify the services that are running on those IP address ranges and if they have vulnerabilities. So hopefully that makes sense. Yeah.
Brilliant. Next question is, shouldn't our blob be accessed with SAS token embedded to it?
Yes, that is absolutely true, Zishan. So in your environment, that's a great policy to follow always. But the example that I showed you, the attacker is the one using the blob storage in this case. So this is not even for the victim. So the victim may even be doing the right thing, but the attacker is taking advantage of Microsoft Cloud Services to deliver a payload in a way that will be allowed through the firewall. So because if I'm delivering the payload using, in this case, I'm delivering the payload using .blob.core.windows.net. That's where my payload is hosted. So it's the attacker that's using it in this case. So in this case, the attacker decided not to have a SAS token associated, but I hope that makes sense to you. So it's not the victim. So the victim, obviously, your environment, you have to ensure that you do that. But if an attacker is making use of that, they could or could decide not to use a SAS token.
Brilliant. Okay, next question is from Richard. Would a secrets manager help in preventing token and identity theft by having such info centralized?
So very good question. So if you're using something like managed identity, Richard, the best defense is to ensure that the application that you're hosting on that service is not vulnerable. Because when you're doing, when you're using a managed identity in Azure, the credential information, the service principal ID and the secret key is managed by the Azure platform. So hence the name managed identity. It's not something that's exposed at any time to anybody. So that's one of the advantages of managed identity over service principal. With service principal, you have a user managed ID and key. With managed identity, you have a platform managed ID and key. So in that case, once you enable managed identity for a service, there's a local exposed within the service. Your application can request for a token using that local metadata endpoint, and then you obtain the token that way. So the best defense in that case, when you're using managed identity, is scan your applications for vulnerability. If they have vulnerability, make sure you have some mitigation against those. And number two, least privilege. Make sure the managed identity is not giving more permission that it needs. If it only needs to be able to access a service in a resource group, only give it access to that resource group. That limits the framework of an attacker greatly.
Great. Zishan's asked another question. What is this JQ after pipe in each command? Nice.
So JQ is just a JSON. It's just a command line tool to be able to pass JSON. So for example, if I run it without JQ, if I run the same information without JQ, it's just going to give me a blob without nicely formatted. So the reason why I have it in a nicely formatted JSON format this way is because of JQ. It's just a command line tool to format JSON responses. So it's a Linux command line tool.
Great. Johan has asked, would CSP prevent this?
So CSP, I assume that you mean like maybe something like a CSPM, maybe something like a Palo Alto Prisma Cloud, or something like Security Center and stuff. So the answer to that is it won't prevent in this case, but it's going to let you know when you have this issue. Because one of the other issues that happen with organizations is they don't know that they have these issues. They don't know that they have this misconfiguration till it's too late, right? So being able to know that, oh, someone just modified the service in a way that's not secure. And by the way, that service is also public. So CSPM will let you know that, and then you can essentially tie that in with some automation to sort of respond to that. So essentially, in some cases, just CSPM capabilities will let you know on a cloud scale, but then some tools have extensions that allow you to be able to respond to that.
Okay, great stuff. Next question is anonymous. Does Azure Security Center do a good job with suggestions on strengthening the security? I
think so. So the answer to that is yes. So it does do a good job to be able to strengthen that. So I think that the question with that depends on what are you using, a single cloud or a multi-cloud environment. That's what determines, one of the things that determines which environment I do. But yeah, the answer to that is it does do a good job. Right, so there are other services, but essentially you can need to compare capabilities. But yes, it's an amazing tool by Microsoft.
Okay, Johan has asked, how about service endpoints?
So yeah, service endpoints mixed with the firewall to block the access to the database could also have helped in this case. So service endpoint and private endpoint, sometimes people confuse both of them. So service endpoint came before private endpoint. Service endpoint is a capability of Azure that allows us to be able to connect to a service from a private network over a private over the private backend. So service endpoint will also help in this case. But what Microsoft have now done is they've extended the capabilities of service endpoints by actually giving a platform service an IP address within your network. So what this means is even if you have an on-premises application that needs to be able to use an Azure private service. Using private endpoints, you can access it through an IP address in your virtual network. So service endpoints, yes, it will help you with that, but essentially private endpoints takes it further by making that platform service available privately through your private virtual network.
Great. Some feedback from Tal Rosenberger. Great presentation, David. And a few questions. What would be the equivalent of AWS VPC in Azure?
So Azure, I like Microsoft. Microsoft just makes it simple. It's called a virtual network. Like VPC, virtual private cloud. Microsoft just calls it. It's a network, right? So it's just VNet. Virtual network is what it's called in Azure.
Great. And final question that I can see, what vault/secret management solutions would you recommend?
Key Vault is awesome, especially if your service is hosted in Azure, like the way that we've seen. Key Vault is absolutely awesome for that, because then you can tie Key Vault in with managed identity to give your application access to that identity, whatever credential that needs to be accessed, that needs to access and retrieve in the service. So Key Vault is an awesome one, so I'll absolutely recommend that. It's a good one. There are other ones like the ones by HashiCorp, but I don't have as much experience on that to be able to recommend or advise, but I know that Key Vault is good.
Okay, another question's just come through, anonymous. Is there an open source repo, PowerShell or other, with some monitoring or resiliency tool you could recommend?
Some monitoring tool. So I assume that you mean something that you can use to assess your environment, to be able to see is something vulnerable, is something not vulnerable in it. Yes, so there is a repo for Azure GitHub. So if you check out my Twitter account, I think what I'll do is I'll put a repo for Azure GitHub. So there is a repo that contains Azure policy documents that you can use to essentially do a quick assessment of your services. So I'll put that on Twitter. So check out my Twitter page. I'll put a link out there.
Great, that's all the questions that have come through, and some more great feedback, people saying thank you for such a great session. David, it's been such a pleasure to have you on today's session, and I do hope that we have you back again soon, delivering another session with the Reactor.
No problems at all.
Yeah. Is there a way we can maybe share with people your Twitter handle in case they have follow-up questions?
Yes.
And is that something we can maybe post in the Q&A?
So I can pass that across to you. So my Twitter handle is @Ashegunlolu. I'll pass that on to you, Emma.
Sure,
So that'll be @Ashegunlolu, and also my YouTube channel. So again, we have like a meetup. Just because I understand that Azure security is big these days, but also because there's lack of information about offensive security. So we actually have like a senior security architect from Microsoft, so somebody called Dean Bryan that you may know. So Dean will be speaking for us in the meetup like in about 2 weeks time. So essentially we want to focus on offensive security as a key part of cloud security education, and that's why we started the meetup group. So I'll forward those information to you, Emma. So I appreciate that.
That's great. I'll make sure to repost them then on our meetup to everyone who's attended today. I do just see a last question that's come in if we have time for it.
Yeah.
From Johan. What about using App Service and Key Vault with MSI? Would we still have a scenario like this?
So here's the thing, is that when you're talking about application identity, MFA is not something that can be used. Right? MFA is something that comes into play if you're talking about user identity, because there's no way to programmatically complete MFA for an application. So in this case, you have an application that needs to be able to access a backend database, right? And the application needs an identity to authenticate to be able to access the backend database. So essentially, it's an application identity, which means MFA cannot be used. Right, so that's the reason why it's a bit more tricky in this case. So when we looked at the different types of identities that an attacker could target, the easiest one the most difficult one is the user identity, because again, I have MFA enabled for all your users, but you can't have MFA enabled for your application identities. So you have to be much more strategic in terms of following the principle of least privilege, using secret management principles when you're using those types of identity.
Brilliant. Okay, thank you so much. I don't see any more questions coming through. Tal has kindly posted your Twitter handle in the Q&A, so that's really helpful to anyone who wants to follow up with David. Again, thanks everyone for attending this session, for all your excellent questions throughout. And David, once again, it's been great to have you, and I do hope we have you back again soon.
Yeah, thanks very much, Emma. Really appreciate it.
All right, take care everyone then, and enjoy the rest of your day.